All right, guys, let's continue where we left off. So you should be seeing the slides right now. Okay, so you should be looking at the slides. So this is where we left off. So now we've talked a little bit about, features and everything, samples. Now we're going to talk a little bit about the machine learning algorithms themselves. So just, again, it's just an introduction of what's to come. So machine learning is essential for automated systems to make decisions and to infer new knowledge about the world. There's kind of two things about data, data science, that terminology is a bit of a confused term, I would argue. Data science. That's why I sometimes like to use the terms AI, machine learning, deep learning, and big data. These are really my preferred terms versus the generic data science, because sometimes when people think of data science, they think of two ways of thinking, really. One is automation, where the human, it's not about a human making decisions. It's about full automation, really. It's full automation. Whereas there's another one, which is where the human uses tools for decision making. Now, both of these can use all of these tools, right? Both of them can use them. Sometimes your job is, you make better decisions. You're a trader, in the stock market, you don't have an algorithm that makes the trades automatically. Instead, you look at Excel spreadsheets and you look at databases, and then you run an algorithm on your data, and then it kind of helps you to make better decisions, write reports, things like that. So there is that. And then there's more the automation approach, which is the goal is to create algorithms, techniques, methodologies that will do the work automatically, will learn from data, etc. So I do want to stress when I cover this class, I focus more on this. All right, so I'm more focused on this. I like to use this terminology and not so much focused on this. I kind of think of this more of a data analytics as the right terminology, really. So, this is probably like data analytics or business analytics, right? Whereas this is a little bit more different. And it's just more interesting to me. The idea of that, and within that, we have the tools. So, for instance, this course is about ML. My next course is more about deep learning algorithms, but both of them touch on big data, of course, and AI is kind of the overall encompassing thing, right? So it's really that I want to make that clarification, right, and where everything fits within the scope. So in particular here, I'm saying that machine learning is essential for automated systems, right? So for automation and automated systems to make decisions and to infer new knowledge about the world, to learn, basically. Machine learning here, approaches can be divided into three. So I've mentioned that already, reinforcement learning being the other one. And I think we talked about this before. The difference, besides the algorithms, is that in supervised, you have labels. In unsupervised, there's no labels. And in reinforcement learning, there's some type of label. It's a little bit different. That's why we will explore reinforcement learning later in the semester. And so, you know, we will see that. But basically, you divide machine learning into these areas. So each one of these areas, unsupervised, reinforcement learning, or supervised learning, will have an individual set of algorithms that you're going to use. So now we will talk, once you have the data, so once you have this X and Y, right, that we've been talking about before, now you're ready to build your model. Okay, so now you're ready to build that model. And so you want to think about how you're going to do this. So within supervised approaches, which is the first focus of this course, the learning methodologies can be divided based on whether they, based on what they predict. So do they predict a class, right? Predict a class, or do they predict a magnitude? Right, so what are they predicting? Do they predict a class or do they predict a magnitude? Okay, so the difference is, for instance, you know, when we did Iris, how many classes do we have? 3, right? 0, 1, and 2, Virginica, versicolor, setosa. So we're predicting 1 of 3 classes. In MNIST, if you looked at it, you had 10 classes. 0, 1, 2, all the way to 9. In intrusion detection, you know, we have 2, 0 and 1, which are at no attack or attack, right? Either one. But when we're dealing, so that's when you're predicting a class. When you're predicting a magnitude, you're predicting actually not a class, but an actual value. So the example of this is housing price. Right, so given that I have square footage, square feet, right, square feet, what am I going to predict? What am I predicting here? If I have the housing price and I have, okay, so the house is so many square feet, I want to predict the price of it, right? So I want to predict that the house cost, you know, 250,000 or something. So it's not a class because it could also predict 245, just like it could predict 239, and so on, right? So it predicts a magnitude versus a class. So we have these 2 types in supervised learning. Usually these are called classifiers and these are called regression models. So the classic example of this that you've learned in your stats class is linear regression. Okay, so you learn about that in your stats class. All right, so we won't really focus so much on linear regression in this course, but really we'll spend most of the time just looking at classification, classifiers, and so on. So an additional categorization that's really important for these methods depends on whether they use sequential or non-sequential data. So the idea being, you know, I see in intrusion detection, I see at time step t, 1 instance in time, right? 1 instance in time. That's called non-sequential. But sequential data is where I actually look at time s, and time s then is followed by time s plus 1, and then time s, s plus 2, and then time s plus 3. So I'm actually looking at data that is sequential. I'm looking at a sequence of data from here to there, from there to there, from there to there, right? So I'll give you an example of this. This is, let's say that I want to predict ice cream consumption for this week. right? So I want, you know, have Monday, Tuesday, Wednesday, Thursday, Friday. And I want to predict ice cream consumption. You know, are people going to eat ice cream or not on those days? Based on weather. So I'm going to say ice cream over here. And I'm going to say weather over here. So I'm going to say that today is, right? So today is cold, cold, hot, hot, cold. Based on that, that's the information. Those are the inputs. What would you guys say about ice cream consumption? Eat ice cream, not eat ice cream. What would you say for the week, Monday through Friday?
The ice cream will be consumed more on the hotter days.
Okay, so then let's say, oops, let's say ice cream, no ice cream. Right? That's what you said?
No, I said it will be consumed more on the hotter days.
Well, I mean, more is sure, but here it's just either or to simplify things.
Okay.
Make sense?
Yep.
How did you know that?
I don't know.
You don't know, right? But you just knew somehow.
Well, based on temperature, I guess.
Based on temperature, you found some correlation between temperature and eating ice cream or not. But there's also sequence. Sequence is important. So what that might mean is actually, oh, I wrote this wrong, didn't I? It should be no ice cream, yes ice cream, because this is hot. No ice cream. But actually, what turns out is maybe this one is also yes ice cream. Why? Why could that one also be ice cream?
Because it's right after the hot day.
It's right after a hot day, so maybe this is really colder. This got hotter. This starts to get cold, but still there's a little bit of hotness from the previous, so there might be some ice cream consumption. And so what I just did there is that not only was I looking at the individual ones, but I also consider the sequence. I looked at the previous one. So now we have algorithms that will also look, and they can look back, way back. Do you see that, guys? So this type of machine learning is called sequential analysis. There are two types of algorithms for this, the hidden Markov model, and there's also recurrent neural networks. So another classic example of this is the following. What is called part of speech tagging. So in part of speech tagging, I have the car is going fast, right? So we know that this is a determiner, this is a noun, right? And then we have, you know, let's keep it even simpler than that. The car runs fast, right? And so here we have, you know, a verb, right? And so whenever we have, now whenever we're trying to predict things, right? I'm trying to predict what to give it. I can learn that whenever I see the, what happens? And I name it a determiner, what usually follows when I have the word the and a determiner before? What usually follows as the next symbol?
Noun.
A noun, exactly, a noun. And so I again learned from sequence because I looked at the, right, which is equivalent to like looking at hot, looking at cold here, right? But I also looked at the fact that the previous one was a determiner. And so I have two pieces of information for me to infer that that might be a noun. Does that make sense, guys? So this is a special class of machine learning problems called sequential machine learning, where the two algorithms are hidden Markov models and RNNs. In the deep learning class, 530, I cover RNNs. Okay, I cover the ideas of RNNs. They're used widely in natural language processing. They're used widely in natural language processing. If we had an NLP class, I would definitely cover hidden Markov models. Given that we don't have an NLP class, if time permits, I will cover hidden models at the end of the semester. Basically, you know, start with this ice cream, but it's a topic, unfortunately, since I cover RNNs and deep learning, this is one topic that doesn't usually find room here. All right, but just be aware of it. It's sequential. However, if you have an interest in learning more about hidden Markov models, let me know and I can you know, give you a little bit more information about them. They're actually useful for a lot of other things, not just for NLP. They can be used in a lot of problems. Any problem that you can think of that might be sequential, maybe in finance, right? The stock market, you know, how is the stock market doing this month, last month, you know, and so on, might help you to predict how the stock market will be doing next month, plus looking at whatever the current events are. So certainly an important area, sequential machine learning. However, most of what we'll be doing initially in an introductory machine learning class is going to be just time step one, right? At one time step, and so it's non-sequential. All right. Any questions about this? Okay, no questions. Here, I'm not going to go through this table, but just I provided it. This is a list of the well-known machine learning algorithms, their definition, pros, and cons. Okay, so we've got from support vector machines. That's one. It's called SVM. Used to be very powerful, but it's been mostly now displaced by deep learning. Decision trees, you've already tried this one, J48 and Weka, right? So that's the decision tree. Neural nets, right? So you tried multi-layer perceptron and Weka. In the deep learning course, we'll be looking at a lot of deep learning algorithms. K-means clustering, so that's for unsupervised. There's linear discriminant analysis, right? So another classifier. Naive Bayes, I usually say this is the baseline. So I would always recommend that you, whenever you can, when your data set is small, usually run Naive Bayes. We will look at, I usually enjoy looking at Naive Bayes and how to write from scratch. So we'll take a look at that at some point. Maximum likelihood estimations, another technique. Hidden Markov models, I just mentioned it, right, for sequential. So we talked about that. All right, and so that's just kind of, I thought I had more than that, but that's just a few of the algorithms that you will see. So just become familiar with the terminology, some of the names, and we'll be using them. You know, some of the time, as you did in the Weka homework, you just gave it a data set, you ran a few algorithms with default parameters, and you look at the results. And for those very basic data sets, the results are usually really good. However, once you start looking at your own data, you will see that the results are not going to be as good. So they're going to be a little bit more of a challenge. Okay. So a few machine learning algorithms. Classifiers are machine learning approaches that produce as an output a specific class given some input features. Okay. And I mentioned all of this in the previous slide. So deep learning. I'm sure a lot of you have heard of this. We actually have our class 530, which is deep learning algorithms. There I take so in that class, I take a bottom up approach, where I really start at linear regression and start building on logistic regression and get to neural nets, deep neural nets, and then the more advanced techniques, like I said, like CNNs, RNNs, and as much as we can cover. So I'll do that in 5:30 for those of you that will take the class. Here, you know, we'll be using deep learning, but we'll be using it without getting so much into like trying to build from a very basic algorithm how the other ones come about. We'll take a more of us, I said top-down, more practical approach, but we should still use some deep learning algorithms to solve problems in this course, although this is not a deep learning course. So deep learning-based methods are simply neural nets with more layers, okay? So what that means is that usually you have your input X and your Y data. So for instance, for Iris, right, you have 4 features, F1, F2, F3, F4, and then the classes are 3, C1, C2, C3. So a neural network is represented like this. And then if there's nothing in between these connections, right, if there's only connections like this, it's called really just a regular classifier, maybe logistic regression. However, if you give it something like this in between, what is called a hidden layer, now you have more connections. Do you see that? So the intuition should be that the more connections you have, the more opportunity you have to learn things. Because it's like you learn, you know, it's like in anything that you do, right? So if you want to understand something really complicated, like let's say like fixing a engine of a car, right? What do you do first? You don't figure out how to build the whole engine, right? You maybe figure out how to fix something of it, the carburetor and then the starter engine, right? And you kind of build it in parts. So analogy-wise, it's similar, right? So here's like you're learning about the carburetor, whereas this one is about the starter. And then over here, you combine starter with carburetor and you learn some more insight about it. Do you guys see that, guys? Does this make sense? Yeah, so that's really the intuition, okay? Now, if I have that, and this is called a neural network. So this is a neural network. Now, in a deep learning, it means that now I'm just like going crazy and adding more connections in between. Okay, so the more connections I have, you know, again, think of that analogy. Well, now I'm learning even more about that carburetor and the combination of that carburetor with the exhaust. And I just have more room to explore things and learn. But if you notice, each one of these connections is a thing that has to be learned. That it's like a variable. So think about it, where it was before we had very few variables, the more layers you add, the more variables you have to learn. So imagine that's just more computing power, and that's why deep learning and parallel computing are needed for this, because there's just so much in there that you really need to be very efficient about it, okay? But that's what deep learning is. So deep learning methods have made a big impact in the field of machine learning in recent years. As of 2012, they've become the dominant set of techniques. Given enough computational power, which we don't always have, they can automatically learn the optimal features to be used in a classification problem. So I'll give you an example right now. So Mitch, your classmate, and I, we're working on a project where we have 70,000 images of one thing, 70,000 images of another thing. And I think the images were like 400 by 500, and GPUs, pretty good GPUs, I would say, were not able to process them. All right, so we had to scale them down to 300 by 300, and it, you know, kind of do a few other tricks to kind of, it makes the process of learning slower, but at least it can complete. And so what this means is that the technology, even though the algorithms are there, we still don't, you know, computers are very expensive, right? So you need to have really powerful machines to be able to process even things like this, okay? Which is not very big, really. But by doing things in batches, instead of giving it everything at the same time, and instead we just give a little bit of it at a time, and then a little bit of it at a time, and a little bit of it at a time, at least we can train with a really large data set. But we're looking at things that can take days, right? Over a few days, this model will train. Now, the great thing about training is that it only needs to happen once, right? So you can afford to train something for a week and then just use the model. So this is the example of this, that Google right now developed something called GPT 2 and GPT-3. Both of these things are very powerful. They're for language understanding. Apparently they can, you tell them to, you know, you tell it to write you a story about Star Wars, and it'll do it. I mean, it'll write a story, and sometimes you'll pick up that it makes errors, but there's some interesting things there that will at least make you laugh. And so it's a very powerful algorithm. It took them a week or so to build these. And now that they are built, all they do is they give them to you. So they'll say, well, it's trained, now use it. So now you can use it, you can give it text and things like that. And the model, you know, it doesn't take a week to use, right? You can use it right away, but it does take a while to train. So in deep learning, it's all about computing power. So that's an essential part. So I would argue, and this is where I usually, you know, will throw in a little bit about, not machine learning is not just about, or deep learning is not just about learning the algorithms, but it's also about learning the infrastructure. Okay, and what I mean by that is understanding the computing element of it, parallel computing, GPUs, or Hadoop. And then there's a lot of tools out there in AWS, the cloud, basically, the cloud. So I can tell you right now, there's Google Cloud, AWS, Oracle, Azure for Microsoft. I don't know if I'm forgetting anyone, but I know, IBM is getting into the cloud business. IBM, and you know IBM has Deep Blue, so they have a lot of AI as well. So certainly for you guys, it's an exciting time. Azure, Google Cloud. Forget the other one. Oh, Oracle. So take a look at these, because probably in the future, a lot of the machine learning will be moving into the cloud, just simply because they will have the resources, the computational power. You know, you can't always buy a $5,000 computer, right? You can't constantly. So when you buy it, it's already obsolete first of all, because the new processor just came out, and also a couple of years from now, you know, it's probably way in the. So usually understanding these is better. We're lucky to have Scholar right now. Those seem to be pretty good. But anyway, a lot of it seems to be going in that direction. Okay, and so there's a lot of certifications out there, and really they're not so much about learning the algorithms, but they are about learning the tools to manipulate the data, tools for using models that are already pre-trained, like GPT-2 and GPT-3. That's what Google feels where they can provide a lot of benefit, is that they can do these things and then you implement them to your own tool. So there's certainly a lot out there, okay? For the novice and also for the expert, you know, you can build your own things, or you can build your own thing, or you can actually use a lot of the tools as is. However, having a good understanding of these topics is actually pretty important as well. And that's why we will do in this class, we'll look at a lot of the things and apply to some problems. All right, anyway, so this is usually when I talk about deep learning, I like to talk about, you know, computational power. All right. Feature engineering, I already talked about that. So we did some examples of that, which is you created features, just be aware of that. That's something that Google or AWS can't really do for you, right? You gotta be able to do that. In the past, I should say that it was, it used to be a full-time job of people to engineer features. Today, because of deep learning, it turns out that deep learning, when you give it enough computing power and enough raw data, deep learning can actually sometimes figure out what best features to use. So in a sense, you know, you don't have to spend so much time developing features. You can just give it all the data and let the algorithms figure it out. So this is somewhat, has changed a little bit. However, it's a little bit difficult to explain when you haven't really struggled a little bit with creating features, okay? But anyway, just be aware that feature engineering, deep learning does have some benefits there as well. All right, this slide, you know, I don't really need to mention it right now. It's just the advantages of what neural networks can do. So I'm gonna skip it for now. I think, you know, just be, you know, supposedly artificial neural networks can do things a little bit better. Now, let's get into some of what's coming up, okay? So the two things that are coming up really are Numpy and Sklearn. So these are two Python libraries that we're gonna be using, okay? They will provide a lot of the things that we need. So you can see Numpy is there. You can see Sklearn is being referenced here throughout and throughout here and throughout here, right? So we will be using these libraries mainly for to be able to solve problems with machine learning, where usually the pipeline is get the data, right? Then process the data in some way, maybe with Numpy, right? And then after that, apply the models or train the models. And that's where Sklearn for now will come in, but then later we will move on to other libraries as well. And then finally, performance. And the performance metrics were all those things that we talked about before, like the F1 measure, you know, recall, and so on, all of those, okay? So these libraries that you see here are the things that will enable us to do that. You can see that already here, confusion matrix, precision score, recall score. So those are the libraries that we will use for that. And then there's a few other libraries. I'll talk about this in a sec. And then you can also see there's this library, Matplotlib. This is for visualization. So that whenever we want to view charts, graphs, right? We'll be doing in the first coding example that we do, we will try to do a little graph just to kind of illustrate the whole process. Now there's this library, Pandas. I don't usually spend that much time on it in this class. You will kind of just have to figure it out on your own, but just be aware it's a pretty important library as well. All right, so these are some of the libraries that we will be using and the reasons why. So Sklearn, let's start there with the Sklearn library. So Sklearn library is the main library for like traditional machine learning. So in a sense, it's like Weka, but in coding. Okay, so now we're gonna look at, you know, like how the coding version of Weka, right, in Python. So Sklearn library is the main library which contains most of the traditional machine learning tools that we will use. NumPy, as I've said, is the NumPy library is essential for efficient matrix and linear algebra type operations, right? When I've already explained that when we're dealing with data sets so that we're efficient. For those of you that ever, if you ever use MATLAB, for instance, right? It's a similar idea. I literally think people looked at MATLAB and said, how do we do that in Python? And that's why they created NumPy. So for those with experience with MATLAB, I can say that NumPy is a way of performing linear algebra operations in Python, similar to how they are done in MATLAB. This makes the code more efficient in its implementation and faster as well. And speed is great. You don't want to spend, you don't want to leave your computer the whole night when you can actually just do the same job in 20 minutes if you had just written the code efficiently. So here, efficiency becomes paramount. The datasets library, for instance, one of the previous ones that we saw, helps to obtain standard corpora data sets. Okay, so this is just another way of getting data sets sometimes when we want to use them. You can use it to obtain annotated data like Fisher's iris and other ones. Now, here's something that's new. In Sklearn, we're going to have these two modules, the train test split or cross-validation. So if you remember, last week I talked about how whenever we have data, X and Y, we really need to divide this data into parts, right? So because whenever we have a model, we say we train it on, let's say, 70% of the data, and then when the model's built, we're going to test it in the remaining 30% of the data, okay? So we need to find a way to do that efficiently so that when we have this data set that we read from a text file, we can split it, right? So that we end up with, we're going to take this and then this and that. So we actually end up with X train, Y train, right? Which is going to be these two top parts, 70% each. And then we also have X test and Y test, right? Which would be this one and this one. So now we'll be able to feed our model first to train these so that it learns to correlate train data to Y train. And then once the model is trained, we feed it that. It's going to predict Y pred, and then we can compare Y pred with the original Y test and establish performance, okay? So to do that, we're going to use these libraries, cross-validation and train test split. So this creates splits in the data, such as 70% for training, 30% for testing. Are there any questions about this, guys? No questions? All right. So
I don't have any.
Yeah, okay. Another thing that you'll see that I will do is using something called the standard scaler, which is something that you do for to scale the features in the data. So what do I mean by that? Let's say that I have feature 1 and feature 2. Feature 1 is the price of your house, and it goes from 250,000 to, let's say, 0 if you don't own a house, right? Whereas your age would go from 0, if you haven't been born yet, I guess, or a baby, and to 100 years old, for instance, right? So what's the problem with this? The problem is the spread, the range, right? So one axis, if we think of this as a 2-axis thing, one axis would be the housing price. It goes from 0 to 250,000. It's that big. But the age only goes from 0 to 100. So if we drew this accurately, that line would be even smaller than that because it only goes from 0 to 100. Do you see that? So the spread here is very small versus the spread here, which is really big. That's a bad thing in machine learning. You don't want that because usually what happens is this one will dominate. The bigger one has a tendency to dominate the smaller one just because there's more richness in data. The differences are bigger compared to this one. So what you usually do when you have that situation is you want to do what is called scaling. So in scaling, now you're just going to take every value and basically place it in a range from 0 to 1. So now the axis, they're both going to be the same from 0 to 1, 0 to 1. And now you just, all these values will be mapped so that these get a little bit more of a spread and these get a smaller spread. But they both have equal spreads. And so that allows for the algorithm to work better. Usually you always, I would almost say that you always scale your data, okay? You always want to scale your data in some way. And there's a lot that can be done there. We will just see a simple example of how we can, the standard thing that we can do to scale our data usually. Are there any questions about that? No questions? All right. Yeah, this in particular, when you're talking about deep learning, you want to scale the data. I'm not going to get into the specifics of the why, but just be aware that, in all machine learning, scaling the data, going from this to that is desirable. Okay. So as we start writing the code, make sure that you read through these slides, that you pay attention. That way, when I start writing the code and you see me write that, or you see me write that, you will know immediately, oh, this is the part that he was talking about the scaling. Oh, this is the part that he was talking about splitting the data. All right, so just, kind of know the terminology so that when we'll do this coding probably next week, we'll start getting into sklearn. And so you will, or maybe 2 weeks from now, but you will start to see it. This is, by the way, this is probably the last time that I'm going to be lecturing so much. I just initially have to give you a lot of background before we actually start coding. What I like to do is, we'll just get into Scholar and just kind of write code, and I'll explain the code as I'm going, but I want to make sure that everyone has all the terminology down and some of the intuition before we do that. All right, so another 2 more very important libraries that are very common are Matplotlib and Pandas, right? So this one is for visualization, very important for visualization, so that you can view your data. So as we move along in the examples, you will see me using these libraries for plotting things, okay? Pandas is very useful for data pre-processing. Usually what happens is as I start giving you assignments, homework, I find that students start using Pandas, because they find code online, and that's perfectly fine. You can use any tool that you want. Pandas is a library very useful for pre-processing large data sets. It is very fast and very efficient as well. So again, I go back to this idea that, as you have a lot of data, efficiency is key. All right. Then when you're dealing with NumPy here, you can always set parameters for NumPy. So for instance, like this, set print options, and then you do that, print all values in NumPy array, right? So when, sometimes when the data is a lot, NumPy has a tendency to not show everything. So if you want to change that behavior or any kind of behavior, you can change the parameters. Okay? A lot of these things won't click until you actually start coding, but again, just be aware of them for now. Splitting the data. So what we were doing over here, right, talking about this, splitting the data, this is something that we will do a lot in the beginning, how to split the data. And so, you know, we want to be aware of that. So let us assume that our data is stored in matrix X, right? We have our data in matrix X, and we have our, so we have X and our labels. Because if we go back, right, so we started, let me go back to where we started. We started here, right? If you remember, you had a text file there. You used load text, and you loaded all of the data in that text file into matrix data. Then we did the slicing of matrix data and ended up with two things, X and Y. And I already discussed how we did the slicing there with NumPy, because we're using NumPy there. So now that we have that data X and Y, what we want to do is we want to split it into data sets for training and data sets for testing. And that's what we're going to do here. In this example, we're going to use sklearn to do it. So if our data is in X and the labels are in Y, so there are two separate entities in the code. The code segment below uses the function train test split. And this function is used to split the data set, in this case, into 4 sets: X train, X test, Y train, Y test. So we take that and that, that and that. And these are the 4 sets that we will use by traditional classifiers or deep learning classifiers. Okay, so the goal will be train with some, test with others, and measure performance metrics. So I think, as I've said before, the sets that start with X hold the data, the feature vectors. And the sets that start with Y hold the labels, you know. So Y1 for the first feature vector, Y2 for the second feature vector, and so on. So Y1, Y2, right? And then the feature vector would be F1, F2, F3, all the way to Fn for one sample, sample 1, and we have sample 2, all the way to Fn, right? So that's sort of the idea. So hopefully it's making sense. So how do we split it? We need to provide some values, the value of the test size. So if we provide the value of the test size, then it infers the value of the training size. We can also provide random states, which allow us, when we set those values to a specific number, it randomizes the data, but it always randomizes it to the same thing. So it's a good way of repeating the same problem. So the value 0.1 makes a train set that is 99%. So 99% of all samples are in the train set, while the test set has 1% of the samples. Obviously, if you put 0.30, then you're going to get 70% for train, 30% for test. You can see that here. The random 42 allows you to always get the same random data, since the seed is defined as 42. Are there any questions about this, guys?
Could you explain a little more about random state?
Random state is the fact that you take the data, right, and you have sample, 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 right? Let's say that it's 1, 2, 3, 4. Then you tell it to randomize. So if you don't specify the number, it's gonna pick a randomization, and you don't know what it is. So it might be 2, 1, 3, 4. However, when you specify 42, it always uses the same seed. So the outcome is that on Monday, you do the split with 42 and you get 4, 3, 1, 2. Then you come back on Wednesday. If you use the same seed, the randomization is the same. So the goal is that you can always control even the randomization by using the same seed. You understand that?
Got it. Yep.
Yeah. So that's really the idea. We don't really care about randomization. So usually you just care that the data is random. And so you don't have to worry about that so much. As long as it randomizes it, you're fine. Okay. And here's an example of how we're going to use it. You'll see we'll have, you know, the data, the 4 variables that we're going to get given the function train test split. We're going to give it X and Y as input, the test size, a random state if you'd like, and then we're going to get these. And those four are what we're going to use. Okay. If you get a data set and you just kind of want to keep the whole data set, usually what I do to simplify things is I just give it test size of 0.01, so I retain the majority of the test set basically. So these will have, so this one and this one will have most of the data, and these two will only have about 1% of the data. So I can discard it if I'd like. It's just a little quick way of getting the data, but you know, there's lots of ways of doing it. All right, so that's splitting the data. Hopefully the idea makes sense. We will do this as we start writing some of our code. All right, so in the next set of slides, I'm just going to show an example of sklearn and how we can call the algorithms in machine learning. So this is the most standard approach. It's kind of like a little bit more complex than Weka because it's not GUI, but at the same time, it's pretty simple. Okay, so it's really pretty simple. So we have an example of 5 common classifiers. And you'll see the data sets that you give them basically after the percentage split. They'll be normalized. And so, you know, it's basically an illustration of how we can do things. So you can see that here, right? So basically all you do is you can define functions like, let's say, logistic regression, multi-layer perceptron, KNN, random forest, SVM, right? So these are basically functions that you will define in Python. And notice that what you give it is the data. You will give it X train, Y train, X test, Y test. Notice that whenever I wrote the word normalize in there, just so that I know that it's not the original X train, but it is the X train after scaling. Right, so after scaling has been performed, then it becomes X train normalized. And you really, all you have to do is that. You take the entire data set, run it through the function, and now your data is scaled. Okay, just like we said before. So we will do this again, but you know, this is just an explanation of the code before we do that. And it's the same approach. I use another algorithm, SVM, same idea. X train, Y train, X test, Y test. I give it random forest, X train, Y train, X test, Y test. Now, if you've been looking at this, you probably noticed that the X's are normalized, but not the Y's. Can anyone tell me the reason why that is? Why do we only normalize the X data, but not the Y data? So we got X over here and Y.
Because probably the X is small when compared to Y, so we gotta scale it.
Well, you scale the X data because in the X data, you might have, like what I explained before, you have 1,000, 4,000 in that feature. But in this one, you have 0.5, 0.2, 0.7. You see that the spread is very small here, right? And it's much larger there. You see that?
Yes.
That can happen in the X data, right? That can happen. I mean, we saw examples of that. But in the Y data, what are the labels usually? If we have a 2-class problem, what are the labels? 0, 1, 0, 1, 1. That's it. Yeah. So there's no need to scale this because they're already scaled, really, in the sense
that makes sense.
Yeah, in the sense that they're only the labels. And so that's why we don't actually scale the Y's. but we do scale the x's. Okay, so that's an important little piece of information as well. All right, so we're almost done with these slides. So the next topic is optimization. I will leave that for the next time we meet. All right, we will come back to the topic of optimization, given that that's you know, machine learning. If you want to, what is machine learning, right? Well, optimization. All right, so but we will come back to that in next week. So now what I want to do is I want to go back to the, so I've covered a lot of topics, right? But we're going to go back to the topic of getting the data, right? So we were talking about this, how do we get the data? That's where we need to start, right? Sort of here. We want to go from the web to that. That's my goal. The first set of homework assignments are going to be about that, right? So we're going to take the pipeline of, you already know how to use Weka. You already know that. You already know that if you have data in the format of Iris, which was .csv, it'll fit into Weka. But now I'm going to not give you, I'm not going to give you the data set anymore. Okay? Instead, all I'm going to say is get some data from the web. And you have to then, through your magical abilities, coding abilities, you have to get that data in some way, that txt file. And then from that txt file, you have to figure out how to make it end up like that, X and Y. So you want it to end up like your X and your Y. You need to define the features. You need to define the labels. And then once you have this, it'll be in that format, and then it can, your goal is to eventually load that data set into Weka itself. Okay, so it's not going to be very large, but it's something that you're going to build from scratch, and that way it'll give you an idea of the challenges. Again, am I saying go online and find a data set that already exists? No. I'm saying you're going to have to scrape some data from the web and then structure it and then figure out the whole pipeline until it loads into Weka. Okay? So let's start looking at that. Usually when I do this, I like to first look at the homework assignment. So let's go back to Brightspace. All right, so we're back on Brightspace here, and we are going to focus. So now, except for the optimization part of the slides, which I'll finish next week, we're done with this module, and now we are ready for these two modules, right, which are homework assignment. So I'll explain what they are. All right, so I've already provided, as you can see, some Python code. Some nice Python code. Can we see this? I wonder if we can see this in this thing. No, I have to download it. Yeah, okay, that's fine. All right, so I'm going to download it. I'm going to download this one. Okay. I'm going to download the data scraping document, and I'm going to download the text file. All right, so I downloaded 4 files, so we'll start there. It would have been easier if I could view these somehow here, so I don't have to share and unshare every document, but I don't know how to do that. Anyway, I downloaded them. So now, close that. I need to go to downloads. All right, so I'm going to start with the Word document.
Professor, we can't see your screen.
Yeah, I need to, that's what I was saying, that I need to share all these things, so it takes me longer.
Now, you still recommend we did this in Scholar, correct?
You don't have to, I'm not gonna like code right now. You just have to, I'm just gonna explain things. But yeah, you can do it in Scholar, or what we're doing right now is very, this is very simple. So you could actually do it on your Windows machine in Python and Anaconda. It's up to you how you do it. I leave that the freedom.
Okay.
All right. So can you guys see the Word document now? Should.
Yeah,
right?
I can see it.
Great. So this is the first task that you have to do. Data scraping, let's call it, right? So what that means is that you're going to complete the following. Dealing with HTML, you're going to find some websites and you're going to download data. You will have to do what is called tokenization. I still need to give you code for this. It's actually not too bad. And that way, we need to take whatever data we have and convert it into features. We'll be also processing RSS feeds, right? So the idea is to process several things out there, and then we will be also doing some frequency plots. Okay. So the problems are simple. You have to find 3 websites and you download their contents. Okay. So you're going to clean what is called clean and tokenize the data. Okay. And then you calculate the frequency of the most common words. So you're going to do like a simple histogram of the data. And the histogram just basically takes, counts of things, right? You break things, you put words. So maybe it'll take a count of all the words that you have in that document. And then it's going to give you the count of it. And you're just going to see it as a bar chart. And then you're going to look for insights about the website given the most frequent terms. So this is a bit of a data analytics. So you'll get the charts, the little graphs, and then you're going to make insights of it. Okay. Then you're going to practice doing the same thing with what are called RSS feeds. So you're going to find 3 RSS feeds and download their contents to a text file, I'm assuming. Clean and tokenize the data. Calculate the frequency of the most common words. Look for insights about the RSS feeds given the most frequent terms. Okay, so this is homework number 1, just doing this, or homework, just completing this. Okay, you got to complete all of this. All right, then I need to open this one. All right, in there's another file. You probably saw it. Oh, I need to share it. Now you should be seeing a text file. It just says the data scraping and noise removal homework, right? So this is just copied from this. All right, so you'll complete the following: dealing with HTML, tokenization. So the same thing that I described before. You find the 3 websites, clean them, calculate most frequent terms, look for insights of both of these. Now, once you've completed this, the next step after finding insights will be to take that data and convert it into that X and Y matrix, okay? And then after completing that, you need to think of what are labels, give it some labels, but eventually you load it into Weka. So hopefully now, if I share the slides, this would make more sense, right? So now you understand. You guys are seeing my slides, correct? Yeah? Okay, so now when I say get some data from the web, I mean that. find a website, HTML, and RSS, download it. Okay, you do that. You will do that clean, tokenize, the chart, the graph, frequencies, and insights. That's what the assignment says. Then after that, you gotta go from there. You don't have to do it for every of the 3 websites, right? You only need to choose one, but you have to show evidence that now you can go and make it into an X and a Y matrix. You need to think of labels as well. Okay, so you need to think of labels. And then from there, put it in the format of iris.csv and then load it into Weka. That is the entire pipeline of this problem. Okay, now the whole point of it is for you to think about the issues. Now, this is not due next week. This is actually something that what I want you to do is to try it starting today, and then next Monday will be more of a practical day. Okay, so next Monday, I will help you out a little bit more with this. However, I am providing some code for it so you can get started with it. In particular, I would expect that you guys can solve this on your own, but you might need a little bit more help from this part on. Okay? Right, so hopefully by next Monday, you guys can complete this. Are there any questions?
So is this whole assignment going to be due by next 2 weeks?
Not right. It's not assigned yet. I'll probably give you 2 weeks. Yeah. So, but it's not due next Monday. So I would expect you, to have completed this by next Monday, right?
All right. So we don't have to submit anything in the Brightspace.
No, you don't have to submit anything until 2 weeks from today.
All right. Got it.
The final solution. But for me to, for us to maximize our time, solve this first, and then in the second weeks or next Monday, you would solve the second part of it. Okay?
Yeah, perfect. Got it.
Yeah. And then we will repeat this exercise for the Twitter, which is the next assignment. But for now, let's just focus on this one, which is a little bit easier. So this is easier than using Twitter. So let's, again, go back. I have to share again. I have to share the code. So collect data. I have a script here. All right, and then there's some, so that's some starter code. So if you have your own, if you're just seeing this on Brightspace, I'm sure you can see the files already. Just open this file. Can you guys see my code file? Collect data, py.py.
No.
No.
How about now?
Yep. No, it's visible. You can see that.
Okay, great. All right, so I posted 2 files on there. The first one is collectdata.py. So as you can see, it's got the Python libraries that you will be using. All right, select 3 websites. So it's just an example of 3 websites there. All right, and usage, Wikipedia, PNW, CNN, whatever you want. Then it's got an example of how to read the code using URL open. So that just downloads all the text, right? Then you can print to see the length of it, okay? However, you know, there's gonna be a lot of noise, right? It's HTML code, it's all of that. And believe me, the way that I have this problem, I'm asking you to find insights. If you don't remove the noise, you're just gonna find a lot of noise in that plot. So you will have to do a lot of cleaning of that data for you to find insights in the graph, right? So that's why, you know, why I say that. I provided a lot of libraries here with the goal that you will explore them, okay? Explore all these libraries, see which ones work for you. As I said, this assignment, you pretty much could do it on Anaconda in your own local machine, or I'm sure you can do it in, if you do it in Scholar though, you may need to install some of these libraries because they may not be there. Anaconda will probably have more of them given that that's what it's for. Okay, so let's assume you've downloaded the data now, and now what do? You want to find what are called stop words in the English language. So those are words that are not very useful, like the, you know, those words are not very meaningful, and so they're called stop words. By running that command, you can get a list of them. After that, you can use these lines of code. They're a combination of using regular expressions. You can see that here, right? Or simple replace. So what you're gonna do is, these are all examples of taking a sentence, finding a character that you don't like for instance, the enter, right? So the new line character, and replacing it with a space or nothing. Right, so in most of these, you know, play with it a little bit. You might need to install NLTK, although I think it's available in Anaconda. This is a list comprehension in Python. It takes all the words and makes them into lowercase. And anyway, so it's some pretty basic stuff, but I've given you a lot of examples already of what you can do, okay? And then once you've done that, you know, you will just run these commands, and this will create a little graph for you, okay? And the little graph will show basically a histogram of the most common words. So for instance, in an election, if you go to CNN, you know, or Fox, you'll see, you know, like Trump a lot in there, and you'll see Biden, and you'll see Democrat, Republican. So all that information, that's what I mean by insight. You probably need to take a screenshot of the website that you use so I can get a quick picture of it. And then when I look at your plot, the words Trump or Biden, they need to be prominent there because they're probably the most common thing. If you did it on the day that there was a major hurricane, then the word hurricane might appear a lot. You guys understand the goal of this assignment?
Yeah, I think I pretty much got it.
Okay, great. So that's it. So I need to see a graph for each website, but if you don't do these steps, the cleaning and all that, the information will not be meaningful. So the idea is to show you that cleaning the data is a big task that must be done, okay? So you will do that with the regular websites. Then you will do that with RSS feeds. Okay.
First of all, we're gonna run these commands on Anaconda.
It's Python code, right? So Python, you need to run it in Python. Where you run it, you know, it's up to you, but it's a Python script, right? So you could run it on your Jupyter Notebook. You could run it on Spider. You could just install a Python IDLE. This will work on anything that will run Python for you.
All right, got it.
Got it? Notice one thing here. You might get a few errors because are you seeing a new file that says feeds? Select RSS feeds? Probably not, huh? All right, so now I've shared the other file called collect RSS feeds, right? So this one simply takes the feed parser, a URL again, and then here's the code for it, right? For parsing and printing out the contents of the information. Same idea as the previous thing with the website, right? Only with this one, I didn't provide all the code because I want you, again, to collect the data, clean it, and then do the plot, the histogram. Does that make sense? You're going to repeat basically what you did with the website, but for RSS feeds. And again, give me plots and insights. Notice that this code is in Python 2.7 because Python 3 would be like that, right? So you just have to be aware of that, okay? Because we'll be using Python 3. All right, so that's pretty much it. So here's the code, collect data, right? And what I'm saying is that after you do the RSS, you kind of have to do that, right? So it's kind of implied. You have to take the data that you collected now from RSS feeds, perform all the steps again, clean it, plot it. I need to see 3 RSS feeds and the graph. This is an easy homework for me to grade because I just look at that graph, look at your website. If I can't make any insights of it from it, I know you didn't clean it properly. All right, so, and that should be it for the assignment that you will work on between today, or the part of the assignment that you will work on between today and next Monday. And then next Monday, hopefully you will do this. Maybe you can share your screen so I can take a look at it if you'd like. And then we will work on the second part, where the second part was really, okay, now we want to, you should be seeing the slides now. Now we want, okay, you got the data, but now we need to load it into Weka and do some kind of a classification. So we have to think, what is the sample? What are the features? What are the labels? Formatting, you know, all that. So that, you know, that will complete our machine learning pipeline. And then after that, the following week, you'll get 1 week to do the Twitter one, which is a little bit different, but same methodology. All right, that is your, this would be your second homework assignment, which will be due 2 weeks from today. Are there, or part A, and then part B, we can start it next week. Are there any questions before we stop for today?
Professor, those websites you mentioned, those are those 3 of them that you put it on like a PNW, or we have to get our own?
Oh, get your own. Do not use the ones I provided. I only put those in there to kind of show for completion of the code, but please do not. Yeah, this sharing is so slow. I can never find where I'm looking for. Are you seeing my collect data now or no?
Yeah.
Okay. All right. So collect data, right? So you mean these 3 websites.
Right.
They're just there for reference. You need to find your own, whatever you want, whatever is of interest to you, you know, do that. But make sure you can find some insights. What I mean by that is I should be able to look at the histogram and see Trump, Biden, Republican, you know, election. And I know, okay, this is about the election. Or I see hurricane, smoke, fire, you know, firefighters, Oregon, and I know what's going on. Do you see what I'm saying?
I guess I'm trying to ask that, is it a certain code to obtain those data, or it's publicly, anyone can get it?
What, these data sets?
Yeah, from the other people, other website.
I mean, you can download any. So what you're doing, so what you're doing here when you do URL open of an address like this, it's literally like if you type that in the browser, right? So if you type that in the browser, it'll show you the website. If you do this line, you just download the text file of it, the HTML with the CSS, JavaScript, all of that in a file, but you still need to clean that up.
Oh, okay, I see now.
Make sense now? Yeah. So
Yeah.
yeah. So you're just what the browser does with the URL, you are doing in code with this. And then Beautiful Soup. So just as a hint, Beautiful Soup might have some functions to say, okay, remove all HTML markup. I put another one on here that the name is also implied, Stripogram. So it'll say, okay, I'm going to take all the HTML and convert it to just a text. So there, or, you know, every year there's new ones. So maybe find another even better library and use that. You're building a toolbox of your tools to do this kind of work, right? Any other questions?
I have a question, one more question. I can't find your, those posted lecture. I can find a calendar on my, and I don't know what's wrong with that. Because I tried.
I don't understand your question. What's your question?
My question will be the lecture you post, like a video lectures in your calendar. I can't find them.
I didn't put the last week's lecture. Is that what you mean?
Yeah. Under what tab do you have them?
Go under,
It should be under calendar, but
there used to be a link on here, wasn't there?
I don't see any more calendar. That's why.
Well, there was a link, I thought. It's possible. Okay, so let me, well, let me do that right now then. So I'm going to put this under Zoom and online information. I'm just going to create a link. Website, I'm going to call it. So it should be there now, correct? So if you go to Zoom and online information, there's a link to website. You click on that, and now it opens a website. Oh, it was under the announcements page. Yeah, that makes sense. And then if you look at it, there's the video from last week. The video.
Okay, thank you.
Do you see it now?
Yes.
Okay, yeah. But I added the link. The link was apparently under the announcements, but I have now added it to the Zoom and online where it says website. You can just click on that. And then I'll post the videos from today, later today. All right, are there any other questions, guys? You have a nice, fun assignment you can work on. And just, you know, have fun with it. Find some interesting websites and you know, do the coding.
Appropriate websites, guys.
Yeah. If there are no other questions, we will meet again next Monday. Currently, this is week 5, but because this is a grad level class, we only have a midterm and a final. We don't have 3 exams. So We don't need to have an exam on week 6. We're just going to have a midterm at the middle of the semester, and then hopefully I'll have your first homework assignment graded this week, and then please just start working on this. All right. So that's it. So have a good day.
All right. Thank you. You guys take care.